Yeah. So we're giving up on Jeff?
I think we're giving up on Jeff. Yeah, I'm sorry to say.
That's okay.
Is this on now already? Okay. I am so delighted to introduce our speaker tonight. Doug Cutting is the chief architect at Cloudera. He was going to be introduced by Jeff Numberg, but I think Jeff is probably having trouble parking, so he may add some color at the end. They've known each other for how many years?
A long time.
A long time. And we're in a band together, no less.
And Jeff sang on roller skates.
I want a video of that.
There might be one.
Probably.
So you have better stories about him than he
Yes.
Perhaps.
Okay, so here goes the straight introduction. Doug's an advocate and a creator of open source search technology. He's founded several successful open source projects, including Lucene, Nutch, Avro, and Hadoop, most well known. He joined Cloudera in 2009 from Yahoo, where he was a key member of the team that built and deployed a production Hadoop storage and analysis cluster for mission-critical business analytics.
It's a terrible sentence.
Doug holds a BA from Stanford and sits on the board of the Apache Software Foundation. And today he's going to speak to us about challenges for the data ecosystem and how we might address them. Please join me in welcoming Doug Cutting.
Thank you very much. It's a pleasure to be here. I was saying this is an amazing building. As a kid, I used to come down and run around on the campus. I grew up in Napa County, where I still live, and always was amazed by this building. So I don't think I've ever actually been in before. So it's neat to be here at the Academy. I'm not going to present. I'm not an academic. This isn't really research results. I'm much more of a practitioner who shoots from the hip, and so these are some opinions. I'm hoping that we can have some fun discussion at the end that'll provoke you a little with some thoughts. So I want to just jump right in. We're really, I think, in a pretty exciting period. The ground has changed beneath us in computing in the last decade, perhaps. I think there's three things that have really driven this forward. The first one is one we know well, that I think we also don't appreciate how fantastic it is, has been the 50-year gift that Moore's Law has given us. May not continue forever, but it's resulted in just phenomenally cheap computation, and not just computation. Networking, storage, memory, every aspect of computing has been increasing exponentially for so long that the ways that we think about computation really changed from sort of thinking about unit computations to thinking about mass computations. And I think that's it's high time there was some sort of phase transition. I think we were ready to start thinking about computation a little differently based on that history. Second sort of trend I think that's underlies this transition is really related to the first. We've now got computational devices everywhere. We've got them in our pockets, on our wrists, in our cars, on our trains, in our planes, all over the planes. I don't know how many instruments there are recording stuff in tractors, in buildings. Pretty much every area of human endeavor is instrumented these days, and if it's not, it will be soon. As we can afford to, we're finding value in being able to measure things, see things, actively control them. The opportunities are seemingly endless. We're seeing industry after industry transformed. Mark Andreessen's famous quote about software eating the world, I think it's really about the degree to which every industry is turning into an IT-based industry. That the companies and institutions that are succeeding are those that profitably deploy IT, and the ones that are going to fail are the ones that don't. That it's a key part of the way we need to do things now. Not surprisingly, if we can extend our sensory input with all this machine data, we can see more and we can understand more, and if we understand more, we can do more. We can do a better job of what we're doing already. So not too surprising. Third pillar, I think, is a little newer, and that's open source. Has really turned the software world on its head. No longer are we at the mercy of big companies, at least enterprises aren't, that have a cash cow in their product portfolio that they don't want to sacrifice. They want to milk it as long as possible. That's their business. That's what they were built to do, is to make that survive. With open source, we rather have software that's promoted by the people who use it and developed by the people who use it and evolves according to how people use it. And new projects can be invented and become popular without any large institutional involvement whatsoever. So you've now got this very organic, responsive ecosystem in open source that gives you, results, gives you software that is more applicable to people's real problems at a considerably lower cost, and it's more responsive to their needs over time. All around a better way to build software for folks. So I think those things really combined are what are driving this. About a little over 10 years ago, I was working on various open source projects. I'd written a search engine called Lucene, then used that to build a crawler web search system called Nutch, and we're trying to get Nutch to scale more easily. We had scalable algorithms for Nutch, but there were a lot of manual steps, and Google published a couple of papers about the way they were doing things. The GFS and the MapReduce paper. I realized that if these methods were available in open source, that it could really help a lot of folks use them. That they were, at that point, everyone read the papers and was excited about the ideas, but they didn't have any direct relevance unless you worked at Google. And I had friends who worked at Google, and they said, like, it's amazing the stuff we can do. We can just go and process petabytes easily with a few lines of code. And everybody else says, yeah, that'd be great, but we don't work at Google. And I was like, well, I know a way to fix that. We started an open source project, and people will start grabbing onto this. So two of us started working on that around 04. By 05, we had something sort of up and limping. Needed some institutional support. We needed somebody who had a lot of machines to run it on. The best I could do was scrounge up about 20 machines that the Internet Archive would loan me. Mike, my partner on this, Mike Caffarella, was at University of Washington, and he, I think, was able to get 30 machines to do some tests. But really, to show the promise, you needed to run it on thousands of machines. And you also needed a lot more developers than two of us working part-time, because distributed systems are a lot harder to debug. So by end of 05, I started working at Yahoo. Yahoo, we renamed the distributed parts of this Nutch. Yahoo dedicated a team of experienced engineers to really getting this to scale, getting it to be reliable. And by 07 or so, we really had achieved this promise of affordable petabyte scale computing, running on commodity hardware, open source software. So the sort of game changer, I think, really happened then, and people started to adopt it. We started to see Facebook, Twitter, LinkedIn, other web companies just pick this stuff up and run with it. In 08, some folks, not me included in them, started to realize that this could have impact outside of sort of companies doing web search and doing weblog analytics and the sort of Silicon Valley, mafia, and that it might be useful for banks and insurance companies and sort of a lot more widespread applications. They started a company called Cloudera, in '08. By '09, they convinced me that there was a likelihood that this would be interesting. And if nothing else, it would be more interesting than continuing to push on it at Yahoo, but to try to figure out where else we could apply this stuff. Since then, we've really seen Hadoop come into its own and start this avalanche of other projects built around it and beginning to replace it even in a good way. That now there's this vibrant ecosystem. Initially there was just Hadoop with MapReduce. Then we saw engines built on top of MapReduce, things like Hive and Pig, giving you SQL and a data flow language. And now we've seen new SQL engines built that are interactive, things like Impala. We've had Spark out of Berkeley, giving us a much better API than MapReduce. That's also more efficient, more general. It solves more problems. You can use it for real time. Use it for a lot of things that MapReduce is not necessarily a good match for. And it goes on and on. Kafka, I could name half a dozen projects that have now started up in this space and are pushing things along. And we've reached this stage where this has become the standard platform for building data applications. If you start a new data analytic application, or even a data storage application, and many times, real-time processing. There's a wide range of kinds of applications that people are building, and they tend to do it here. It's been embraced by all of the sort of legacy players, Microsoft, Oracle, IBM, all the big players. They haven't offered an alternate story for how you should manage all of this data that you might gather, what sort of tools you might use to process it. Rather, they're accepting this ecosystem as the base, and in many cases, investing in it and furthering it. So here we are. We've got this burgeoning thing. But of course, it's sort of like an election. Winning the election is only the beginning of the trouble, and we've got a lot of challenges going forward if we want to really make good use of this and not see it fizzle out or backfire. And so there's a lot of responsibility, I think, to see this go forward well. I think there's a lot of potential. I think we really can improve society, improve the economy, help things in many ways. There's also room for harm, and we need to find our way through this. So I'm gonna list off some challenges I see, and then hopefully you all will come up with some challenges that I've missed, and we can talk about those as well. So the first one is obvious. It's just that it's a young technology still. People have a lot of technology already out there, and a lot of it has been there for a long time and already solves certain accounting problems, certain security problems. It's embedded. They've got anyway. It's part of their culture in their institutions, and replacing it is really hard. And there's also lots of gaps, lots of holes in this ecosystem that's grown at this phenomenal rate. At Cloudera, we've seen pretty much annual doubling, so sort of a Moore's Law-like thing. Here's Jeff. In the adoption of these technologies, in that we see, Cloudera, we see doubling in the number of employees and a doubling in the number of revenue and customers. But we also see a doubling in the number of attendees to conferences on an annual basis. So if you have something growing that fast, so by definition, every year half the people who are using it are newbies. So you've got just a lot of novelty to overcome in the process. And we will. This is a surmountable problem, just with the passage of time. But it's still something that is faces us every day. That people say, does it do that? And it's not yet. Whereas most traditional tools out there already do these things. Related to this is the obvious challenge of talent. As I said earlier, half the folks are newbies. Folks are not familiar with this tool set and how the options they have. They're used to using a different set of things. There's been a new profession coined, as it were, the data scientist, which you've probably heard more than you like about. Data science has a number of requirements, I think. You need people who are familiar with statistics, who are numerate, and understand what sort of computations one might perform. You need somebody who's familiar with the tools, who knows which tools which computations are possible to perform. But most importantly, you need people who are familiar with the domain, who know what you ought to do, what to try, what's appropriate. The first and the last, I think, are the hard ones. The first one, fortunately, there are a lot of people who relatively familiar with statistics. The last one, there are actually a lot of people who are familiar with domains, people who are already working in them. People in railways know railway. They know what the problems are that they're trying to solve. They've been in many cases knocking their heads against them for decades. And if you ask them, they can help you. And some of these people are actually pretty smart numerically. They just haven't had access to the tools. So I think that's the challenge that we can best address, is educating people about this new variety of tools that are available. And the most important one. And there's a lot of courses, a lot of training that's available, and it's helping address this. And I think that is the right place to be working on this. Next big challenge is just the complexity of it all. And it's a much more complex world than the old way of doing things, which was you define a problem, you put out maybe an RFP for solutions, you get bids, or maybe you just spend a lot of time, if you're doing it in-house, designing something with architects, and you finally decide this is the way we're going to build it, and then you build it, and then you deploy it, and you run it forever because it works perfectly. And it's sort of the way you build a rocket or something like that. In fact, that way doesn't actually work that way well for software. But you also end up with these siloed systems which can't evolve. A lot of problems with that. The new way that folks are doing things, rather, is to load all their data into one place, then perform experiments on it, try out using various tools on it, discover what works best, and then deploy that as a solution. Now this increases the complexity greatly. You've not only got more tools to understand, which I already talked about, but you've got more kinds of data. The payoff oftentimes comes not from having necessarily larger amounts of data, but data of different sorts. If you've got a company that has different divisions, it's frequently unable to combine those data sets productively. I remember Yahoo in the early days, that was the huge advantage of this style. They had systems they were selling ads, systems that were displaying ads, systems that were crawling the web, and all these were running at capacity. They were purpose-built, and there was no way you could transfer the data from one to one of the others and have an experiment that combined the two. But they're obviously interrelated. If you want to show people the right ad, you want to know what they've been clicking on, you want to know what's on the web, you want to combine all these and perform experiments to improve your search, to improve your ad business. And they didn't have a platform that let them. This gave them that. But so you've got more kinds of data, and you've got more people. So each of these axes, where you used to just have one group of people, one technology typically, and one kind of data in a system, now you've got all of these things multiply out in 3 dimensions, which just greatly increases the need for integration at all levels. Different tools need to be able to talk to one another. Anything, security, audit, orchestration, any of these things become more complicated. All the technical challenges, all the social challenges are greater with this kind of an architecture. It is a better way to do things. It is a lot more powerful, but that doesn't come for free. It makes us have to work a lot harder to build the systems, even though we have a better methodology where we can build them more interactively. It's a more complicated world to keep track of. Next, obviously, I would want to break out security as a challenge here. If you've got all these different groups working together with these different kinds of data, you'd like to be able to, in just about every institution, control who can see what. Frequently, this data concerns facts about people that they might want to keep private, facts about businesses that they might want to keep private, and so on. From different subsets of people are permitted to see different subsets of the data, slicing it in different ways. So it's an ongoing challenge. Early on, Hadoop had zero security. Anybody could read or write anything, which was great, very flexible. Early on, we added secure authentication, so you knew who was doing things. And then gradually, we've added finer and finer grained authorizations. And then now we're trying to work at integrating these authorizations that each of these different tools, if you've got a search engine that's doing full text searches, and you've got a database engine that's doing SQL queries, maybe one engine that's doing interactive SQL queries like Impala, and another one's doing batch queries like Hive. You're doing some sort of machine learning algorithms with Spark, and so on. You want to have you want to be able to specify who can see what once. And so it's tricky to get all that integration because these are all built by different groups, which is the strength of this whole ecosystem, is that there isn't any central point of control, but it also, as I said, that creates complexity, which creates a lot of challenges. What else did I want to add about security? Something, but I've forgotten. Well, maybe I'll think of it later. Related to security, but I think actually quite distinct, is trust. Security is a mostly technical thing, and there's certainly a lot of technical aspects of this. Trust is a mostly social thing that we pay far too little attention to when we're building technologies. If we're collecting data about people, which we need to do to get a lot of the value from these technologies, we need those people to trust us, or else they're not going to let us collect it, one way or another. By law, by protests, things will backfire and go bad on us. Either that or we'll fall into some sort of hellish society, but I tend not to go that direction. So it's really important that institutions understand how this works and pay attention to what helps to build trust. And the foremost thing here is transparency. If you let people know what you're doing in advance with their data and what your policies are, then they will trust you generally, or else they won't give you their data to start with. And you have to make it clear and understandable. There's a it's not just down in some legal agreement that they click off. And moreover, it has to be believable. It has to be true. You have to convince them that that's really what you're doing. And I think there's a role for third-party audits in this. And we don't see this being addressed well. We see some of the big companies, each of the big companies that are collecting the data the most sort of want to do this on their own. They want to say, we're building our own little universe of trust, and we know how to do it. And they're all doing it differently. There's no coordination, and I don't feel like they're using it as a marketing play. I don't think like we're actually building more trust. When I talk to people who are actually using these systems, I hear a lot of crazy tinfoil hat stories of people keeping their calendar on one service and their email on another, or putting everything on their own hard disk at home and then having some crazy backup encryption plan. And people are doing, at least maybe I talked to the wrong people, but doing a lot of crazy stuff, going out of their way because they don't trust these institutions. And I think we have the possibility we're going to leave a lot of value on the table here. I think we can, use data about utilities to, help with climate issues. We can use data in education incredibly well. I don't know how many folks know the tale of In Bloom. This was an effort by the Gates Foundation to build systems that helped in schools, elementary schools, high schools, I think, that would, among other things, gather data about students that they could aggregate and use to improve the educational outcomes. And it got abandoned after a couple years because nobody trusted them. They were like, people's read on it was, Microsoft wants data about my kids, probably to sell them something. And it was the Gates Foundation trying to do things right, but they somehow didn't manage to convince people that this was a good thing, and that's really unfortunate. It's a great way to improve educational outcomes is to understand what's actually happening and use these kinds of methods. It's what we need to be doing, but we need to trust the folks who are doing it and build up the right mechanisms that support them. And I think we're hearing more about this. We just saw today in the news or was it yesterday? Today or yesterday, the European High Court ruled against Safe Harbor. You guys may have seen that in the news, saying that it's paraphrases. I'm not an attorney, but that companies, if they want to store people's data, European citizens' data, that they're generally not allowed to do so on servers in the U.S. Because Europe doesn't trust the U.S. to keep your data private, roughly speaking. And that's an unfortunate outcome for all of this. It's an impediment to systems, and there's been more of these out there. It might well be a reasonable outcome for the European Court. I don't mean to be critical, but I'm critical overall that I think we're not taking this seriously as an important challenge. And last, I want to just close with what I think is sort of the meta challenge in all this, is that things are changing as a matter of course now. We had a relatively static system before. I mentioned this evolution of the open source ecosystem without any central control, and that's a real source of quality and advancement for all of us. But it also means that we have to be able to change too, to use these, and we will. People, I think, are going to be a gate on the rate of change to some degree. But also, if some institutions, some societies, some companies are able to change more quickly, they're going to take advantage of new technologies sooner. And there's changes not just in the software ecosystem. There's changes in the hardware ecosystem, I think, are going to continue quickly. Changes in the sort of deployment ecosystem, if you will, in cloud, in containerization. There's a lot of trends out there. Things are moving quickly, and I think accelerating in technology. So it's a concern. It should be a concern. If you're in here, you need to plan on change in a way that you used to be able to get away without doing. My dad was in the steel industry, and I think over the course of his career, steel industry didn't change all that much. They might have gotten a little better X-rays for X-raying welds, and maybe some better welding technologies, but not phenomenally better or different. In my career, I've seen a fair amount of change, but I wouldn't say, think maybe one turnover of technology. I think we're going to start seeing turnover of technology every 5 years, 2 years. Hard to say. How quickly we can tolerate it. But it's something we need to accept, and we need to plan on and engineer around this changing platform. So, closing, I just want to say I'm actually optimistic. I think we sort of been this battle to change the platform, the technologies we're building systems around, and the way we build them. And I think we've sort of come through that with a clear victor in this open source ecosystem. And I'm optimistic we can enter an era sort of which I call PAX data, when we'll be using data to better understand our industries, our lives, our society, and being smarter about the way we run things. And I think it's going to be an exciting century for that. We do need to. It's not a sure thing by any means. We need to pay attention. But as I said, I'm optimistic. Those are the challenges I came up with. Curious to hear your questions about any of those or anything that you think I missed. Thanks.
If you have questions, please speak into the mic so we can.
Okay. Okay. So my question is regarding the last point, change. So I mean, it's a fact that nobody likes changes in their lives. So how was it difficult, or how challenging was it to move from those traditional technologies to the open source technologies, and what actually really made that change possible?
Well, I mean, I never made that change because I was never a user of traditional database technologies. I've always been sort of out in left field. You can ask Marty, or Jeff. So I can't give you so much a personal story there. But at Cloudera, we work with a lot of customers who are going through this, there's a lot of people who really resist, and there's a lot of people who really jump at it. And you see both kinds in every institution. People who fight really hard, but also people who are just eager to keep moving. So I don't know if it's a personality trait or what. But institutions can change. It takes will from the top in order to permit them to change. And you see a lot of sort of skunkworks projects. Companies don't like that. They try to shut them down. But the smart ones embrace those. And encourage them. So it's going to happen, whether people like it or not. And if folks don't embrace it, they're going to fall behind, I think. So.
Thank you.
Thanks, Doug. Nice talk. I hadn't really thought about, or I guess wasn't aware that IBM has adopted the Hadoop ++ stuff instead of their traditional software. That surprised me. And I wonder if you can reflect on that a bit. And also, I was also interested to hear that Cloudera is taking on these big organizations with legacy software. And having spent some significant chunk of my recent time trying to help move people from old legacy software to new software, it's really hard to do. And I'm wondering, like United Continental, they're having trouble. All sorts of insurance companies and banks really have trouble doing it. It's generally not successful for a wide range of reasons. So I would like to know about some more details about what success or not success stories Cloudera has with that.
Sure. So with IBM, I think their Big Insights product is what they call it, is their version of Hadoop. And then they've got all these things that are built on top of it. And I think they call them all big this and big that, big sheets, big various stuff. But yeah, and they recently announced that they were going to invest heavily in Spark. So they claim to be all in on this stuff. In terms of what we've seen at big institutions is, so we've been working with banks credit card companies, those are some of the early adopters, telcos. A lot of the times what it is they've got some way they realize they can really either make or save a lot of money for the company. At a bank, they can do a better job of, or they can reduce their loan default rate by doing a better job of predicting who's going to make payments on the loans. That makes a huge difference to a bank. There's also some regulatory things where they need to understand what their portfolio is across all of their different lines of business. Banks, have grown through aggregation, through acquisitions, and so they've got several different retail brands with different back-end systems. They've got different investment brands with different back-end systems. They've got different loan businesses and so on. And to be able to understand, get a global view of what their business is doing, where they're invested, is very valuable. Again, that global view also helps them a lot with marketing. And this is something we see across industries.
Well, let me restate the question. Is your software offering anything new that makes it easier to update this old legacy software? Because it's really hard, and most of these upgrades fail.
So,
as we were seeing with United Continental, for example.
So the things we're doing that we do a lot of work to let these applications, help these applications succeed. So we've done a lot of work on security and security and coordination across the tools, and a lot of integrations so that you can pass data back and forth from legacy systems into Hadoop. So I don't. Curious to see what the failures that you've seen. Failures of people adopting new technologies is what you're talking about. We've seen a lot of successes, and we've got hundreds of customers, many of them banks. Visa had a system that would only store, I think, 30, 60 days of transactions that they were using for their fraud detection, and we were able to let them store 5 years, and they found a bunch of fraud patterns using the exact same algorithm. So one of the ways that we let people transition is by providing SQL engines. So they've got a lot of tooling already in SQL, from visualizations to things like fraud prediction algorithms. And we can then use that same SQL code against now a much larger amount of data at a much lower cost, and make things possible that weren't before. So that's an easy way to integrate some legacy knowledge, is by having that compatibility. SQL is a standard, provides a lot of compatibility. Then there's lots of things for import, export. Okay, I could go on. But
you must not be answering the government calls for help.
Well, I think that you're talking about the government not making.
I think it's easier to change private sector firms than it is to change the government. Yeah, I'm sure there are huge problems. I have a different kind of question. I'm an economic geographer initially, and one of the things that's clear is that a lot of the innovation, and the software ecosystem is being built in the Bay Area. And I'm curious if you see other places where there's innovation sort of in the data software, ecosystem as you describe it, or is it still largely here?
A lot of the companies are in the Bay Area, and also a lot of the people are in the Bay Area. Certainly with open source, you've got the potential to get people from a much wider range of places. And we're seeing that. There's a lot of, we call them virtual employees who are able to stay at home wherever they live and work for companies in Silicon Valley. And that's becoming more and more common. It used to be, people didn't trust that, just like they didn't used to trust open source. But I think there's a lot of that. You can use various Google Analytics tools, searching for tech keywords and see where people are searching from. And there's the normal spots where the growth is hottest, in Seattle and Boston. India is huge.
So there are two questions. One is, I think one is the first one, which you said, where's the innovation happening? And that may be distributed as well. It may be that you have employees now all over the world that are contributing to it. But the companies are being started here is still something. But then the problem with this is that it also goes to the application of your tools.
I think
and that is obviously much more geographically dispersed.
the companies are started here, I think, more because of the sort of VC culture, the way that companies are capitalized. If you want to, and there's a fair amount of talent in the area as well. But there's also, I think, the talent is spreading considerably. And you used to hear a lot about offshoring. I don't think people call it that so much anymore, so much as they're opening a development center in some country that's actually part of the company. And I think that's, Cloudera, anyway.
That's great, thank you.
Thanks, Doug. A great talk, interesting set of problems. For me, you ended with just a reference to the quality of the software, and you gave credit to open source for that. But I wondered, normally our reflex assumption of that is about Linus's law. And yet the picture of complexity and security and new people and diversity, I just wonder, can we instinctively rely on Linus's law as this dramatic Moore's law-driven growth that you've projected? Is that a law? If A, it really is the secret of quality, is it one that scales in the same way that the software and the businesses and the complexity is scaling?
I don't think it's a guarantee by any means. I see open source is more like a sort of a free drug for software, in that it gives you this unfair advantage for your software to accelerate. Anybody who's trying to do something as proprietary software is taking a big penalty today. Whereas if you start an open source project, you've got a much better chance of a lot of folks jumping on your bandwagon and trying to help you make it better. And so it's due to open source that we're getting so much more software in these areas. The quality versus volume is a valid issue. I don't think the story about quality is any worse. I think it can be considerably better when you have, having worked at companies on proprietary software, you tend to be shipping one, maybe two products that actually use some software. Sometimes you're building a really general purpose platform, but when you're working on an open source project, you're much more likely to be building something that a lot of people are going to share. And so the variety of uses tends to be higher, in my experience, certainly, on building things, even things that I think of as platforms. And so that gives you greater scrutiny and makes you work towards greater generality. So it is a sort of the Linus's law, which by that I assume you mean more eyeballs, right? So I think there's definitely some effects there. I think there's some truth to his law, but I don't think it. If you're working behind closed doors, what incentive there is there to produce higher quality software? I don't think there's on the face of it there's any reason to expect proprietary software to have fewer bugs. I think we're seeing a greater volume in open source for sure by its nature. Tends to encourage that and is powering this growth we've seen. And I think there's a few arguments that the more eyeballs one, and you do get more eyeballs, right? Along with that's what's fueling the growth. My sort of simple-minded recipe for a successful open source project is you want to start with something that is usable just barely. But that a lot of people might want to use, and get it out there, and then more people will start using it, and it's that use that then drives the need to contribute because it's not quite what they wanted, and so use is the first step towards getting people to contribute, and once they're contributed, then you've grown the ecosystem. You're no longer just a generator of software, but you've got a group of people who are working together, collaborating. Yeah.
Hi, Doug. Thanks for the great presentation. I have a question. It's kind of, I'm asking it from the smart city, connected city kind of perspective. because there is this huge drive now for cities to go big data, go connected. So I think in that regard, I want to ask based on the clients that you have worked with and how people approach this big data as a tool, right, to solve some problems. Are there any kind of guidelines for cities or new client who want to use this big data, but it's kind of not very clear, how exactly can I use this to solve my problem? So I just wanted to hear your thoughts or experience in this regard.
There are some nonprofit organizations which are trying to facilitate use of data in public sector, and for various social goods. There's a group called DataKind, which has done a lot of neat work. There's who are the folks who are doing there's a lot of work in DC on making better use of data in government. I'm forgetting the name of the organization, but so in terms of guidelines, I think what sort of an answer to Marty's question about what we give companies is another thing that we see is, so we see, first one bank uses this stuff for fraud detection, then another one, and then another one, and then we've seen 10 of them, and the 11th bank comes to us and says, we have a fraud problem. What do you suggest we do? And we say, well, we've had 10 people and they all do this. And so we're starting to work as a company to characterize these use cases in pretty detailed characterizations. I think that's a step towards these actually becoming applications, and I think it takes a long time before things crystallize and people see a clear thing you can package and sell over and over again. Fraud at banks is a huge one. In telephone companies, they all want to look at churn, which is how customers are switching telephone providers and better understand it. That's the problem that comes up again and again. And there's hundreds and hundreds of phone companies around the world trying to sell phone cards, and they all need the same solution. So somebody will come up with something for that takes, and they're combing through all of their call data and trying to better understand those customers. And I think the same thing can happen in government, and is beginning to happen. But I think we're still sort of at that blueprint stage. You've got municipalities, you've got counties, you've got states, you've got countries, and they're going to have similar problems. And so we're, as I said, at the early stages. And so that's another. I can't give you any great examples there. We do work with federal agencies also on fraud, looking for fraudulent claims for benefits of various sorts is a big application. So I don't know to what degree the same methods are used there as looking for financial fraud in banks. If you're looking at the IRS and Social Security Administration, folks like that have found value there.
So I wanted to ask about, I guess for want of a better term, data literacy, which goes to the issue of trust and skill level and just the general public mindset that greets all the talk or hype or whatever about big data. And around here in particular, Berkeley, there's been a fairly ambitious initiative to make something like data literacy, data-driven reasoning, whatever you want to call it, a part of the curriculum and perhaps even a kind of required element of we're talking about the undergraduate curriculum now. And the iSchool has been sometimes enthusiastic, sometimes skeptical, but participant in this kind of talk. So, and I realize this is a very vague way to put it, but I'm just wondering what your thoughts are.
I'd be really interested in consumer ways to measure consumer data literacy. How do most people imagine the data that's stored about them and how it's used, and how is that changing? How are they becoming better informed or worse, and how deep is their understanding? I remember in the 90s working on web search, and I saw over the course of 2 years, I believe, the average number of search terms that people used increased by 50%. And that was clearly people were learning more words are better as a society. It was a very, very clear, broad change across those. I've read studies that say that younger people are more likely to have configured their Facebook privacy settings than older people. You know, we hear a lot of the kids don't care, but if you look at the data, they actually care more. The grown-ups don't understand. How to do it is more, I think, the characterization. And so I'd love to see more things like that to understand what's sort of the baseline that you can then speak to people from about what we ought to do and what's being done, because these end user license agreements and all this kind of stuff is clearly not the right level to explain things. I think vaguely related, the Creative Commons has done an interesting job of trying to simplify licensing down to these very simple properties, and you can combine them in a few different ways and come up with a language for licensing. And it'd be interesting for somebody to try to do that with privacy. Come up with some simple icons, like you do for laundry and your shirt collars. There's the international things which tell you how hot to wash it at, and we need something on websites that tells you something similar like that. But it's a design process and to inform that design process, you first have to know what do people think's going on right now, and I don't know that much.
And just to put the emphasis a little bit differently, looking back on your own experience, at Stanford when you were taking my courses and stuff. Would you see? You were a symbolic systems major, if memory serves it. Or
I was there before there was a symbolic systems major.
You would have been had you.
I was a linguistics major.
Yeah. Would you see a bigger role for statistical-based reasoning, whatever, in that kind of curriculum, or in the curriculum in a general way?
It depends on what you mean by statistics. I mean, I think in terms of advanced modeling, is I think what a lot of people think about. And I don't think you need that much of that. I mean, that's great stuff, but I don't think everybody needs to understand that. But the sort of basic understanding of probability, so yes, it's just short answer. I think some good broad understanding of statistics is critical to make it in society these days. I'm pleased to see, my oldest son, the guy who coined the Hadoop word, is now in high school, and they've got a statistics course that he's taking. And there was no statistics in high school when I was there. Same high school. So that's a control. Yeah. I remember working with John Tukey, and I liked, Tukey was frustrating in many ways, as you probably recall, but I really admired his approach, which was very common sense. If you couldn't explain it in short words, then it was probably not worth understanding. And everything that he worked on, he could explain to you very simply. He'd only do it once. And then if you didn't catch it, then too bad. But
You're a lot more honest about it than I am.
Hi, so we were just talking just a while ago about the difference between being a data science and software engineer. And whenever we go to companies to interview for data science roles, they just end up asking questions about data structures and algorithms. So it's been really hard to get our foot into a data science role. So I just want you to talk about, how would you get experience as a data science? How would you get your foot in the door to become a data science? Like, what would you recommend? And just talk about how companies, I don't know if companies are having trouble understanding what a data scientist does, and just your ideas on that.
yeah, I mean, first I think there's a disease in the industry, which is these interview questions and challenging people and encouraging their performance anxiety and all these sorts of things. It doesn't really help you hire good people. It's a hazing ritual. And I'm so glad that I already have a job every time I hear about those. And I would not like having to write a sort algorithm or challenge, answer some logical puzzle in a room on a whiteboard in front of an audience. So I wish companies did have better ways. That said, I don't know a good way to hire people. I mean, the best thing to do is to survive the hazing ritual and get some experience and have people know you. I think in the end of the day, what really helps is if you know people who've, it's a small world in technology. And the best way to hire is to hire people who other people you work with can vouch for. I think, tried and true. So whatever it takes to get the foot in the door, I think getting the foot in the door is the critical step. And so, unfortunately, the only way that a lot of people will let you do that is to answer those silly questions. I don't have a better answer. I mean, I think it's going out and doing some, okay, I can try a little better. So these things like Kaggle, getting involved in open source projects is a huge advantage. People see open source software on your resume that you've contributed to. They can go look at your code. They can see what you do. And that's wonderful. And maybe they've already worked with you. If you collaborate on a project at a company with folks at a company you'd like to work with, then that gives you a huge step. There's also various contests that people put up that you can compete in if you've got the time and you've got the know-how. Kaggle has all these different challenges. Kaggle tried to create a marketplace for getting people to compete to solve data science problems. I don't know how well they're succeeding with that, but it's a neat idea, and it's a way to do work which you independently, which you can then show to people and demonstrate you've got experience in data science. Other one would be look at somebody like DataKind, and DataKind. Yeah, you can look them up, and they're doing pro bono work. And if you did a volunteer project with them, it's a way to get to know people, get some experience that you can point at because it's in public, and I think that kind of thing on a resume would go a long ways.
Thank you so much.
Oh, you're very welcome. Oh, did you have a question?
Skunkworks earlier, and I've never heard that before.
Skunkworks, I think, comes out of the military in the 50s, probably. But the way I use it is to mean an unofficial project to build something that's not sanctioned by management. What's that?
An infrastructure project that a programmer wants.
For example? Go ahead.
Isn't it something that's usually separate from the main corporate efforts?
Well, yeah, it's because it's a pet project. Yeah, pet project would be another word for it. I think it was actually, does anybody know the history of Skunkworks? Yeah. It was people doing the...
There were many secret programs, the U2.
Right.
The SR-71, it was in Burbank. And this guy basically led the whole project. And there were all the secret projects. And I actually know some of the people that worked on the Skunkworks. And it's a fascinating story. You should read about it.
And they didn't have approval from on high. They were just sort of doing their own thing?
They had it. It was very secret. And so in order to keep it extremely secret during the Cold War, there were key generals that knew about it, but they wanted to keep it as secret as possible because there were all these leaks. And I actually went to see the old plants, and it's pretty interesting. If you go to Ames Research, it's one of the U2s that are from the Skunkworks project.
Shadow IT is another term I hear that's I think, related, that people in IT fear a lot, is that people are going to develop their own systems. It's sort of like when PCs first came around, people stopped using the mainframes and they started doing things on their PCs, and this made IT crazy because they had no control over what was on the PC. And so shadow IT is this notion that you build your own systems because IT says no, and so instead you do things separately.
It's significant that when Xerox decided to start Park, they looked for a place that's far from corporate headquarters.
Right.
And the idea PC was
speaking of geography, yeah.
Right.
Away from it. Just a chance.
I mean, so I talk with a lot with people from IT, and my recommendation for how to avoid that without also stifling creativity is to create sort of a playground. Set up a system with some data and say, please come play on it. We've got the data, we've got the system, you can use it for free up to a certain amount, And so you make it, you try to attract people onto the company standard platform by making it which is now more possible to do. It used to be really hard. You had to keep people out because it wasn't built to do anything more than one thing. But now if you've got this general purpose platform, then you can overbuild it a little bit beyond what you need very inexpensively, and then invite people in. And so you can sort of avoid those problems of building these little side fiefdoms that are unmanaged. So.